So this is project 2 video demonstration. This is a function generator. I have the screen application running in my terminal on my Mac, and it is relaying keyboard presses to the Arduino. You can ignore most of these wires. The only ones you need to, the ones that are actually important for project 2 are these three, and this is power, and that chip, which is the digital to analog converter. And then I've got the oscilloscope probe hooked up to this thing, and you can see by default when it powers up you have this nice wave, 100 Hertz 50% duty cycle square wave, and that's what you see on the screen, 100 Hertz 50% duty cycle square wave. So in our project we had to be able to change from a bunch of different waveforms, a bunch of different frequencies. So when I hit W, it changes waveform to sine, and then to sawtooth, triangular wave, absolute value of sine, semicircular wave, circular wave, bell curve wave. When I hit D, it changes the duty cycle, and F changes the frequency. I have the requirement was 100 Hertz to 500 Hertz and back to 100. And this is what the function generator is outputting. I have the oscilloscope on averaging mode so that it will slowly appear to be morphing from one wave to the other, but really it's instantaneously changing. Here I'll change it back to normal. This is what it really looks like when it changes from square to sine. And then to sawtooth. This is a triangular wave. This is our absolute value of sine. Now we're getting into the custom waves that aren't required by the project. The triangular wave wasn't required either. This is a semicircular wave. If you zoom in on it, it's actually a half circle. Each period of it is a half circle. And you'll notice that this is actually stepwise. It's not continuous. This is how the project works. It outputs one frequency for a certain amount of time. For a 100th of the period, it outputs that voltage level, and then outputs the next one the next 100th of a period. And so each wave you see has 100 distinct levels per period. So this is the circular wave. Each period is two semicircles connected together looking like a sine wave, but it's actually much more round than a sine wave. And the final wave, the bell curve wave, where it's just a bunch of repeating bell curves. So if we change the frequency, looks like that. And now I'm actually going to change it back to averaging mode because that's much cooler to watch. So yeah, when you change frequency, as the professor likes to say, that a new wave spawns in between the existing waves. Just on averaging mode. It doesn't actually look like that, the output, but averaging mode makes it look cool. So this is 500 Hertz, as you can see from the readout. And back to 100 Hertz. There, 100 Hertz. So this is the next wave, the square wave, and you change duty cycles. There you go, 60% duty cycle, 70%, 80%, 90%. You can see the readout here is keeping track for us. 10%, 20%, 30%, 40%, back to the original 50%, and we'll change frequencies. This is so entertaining for me, just watching the new waves form in between the other existing waves. So this is 500 Hertz, and then we'll change waves. There you go, sine wave, back to 100, 200, 300, 400, 500, and this is the sawtooth wave. This one's probably the most entertaining to watch change frequencies. Triangular wave. 300 hertz, 400 hertz, 500 hertz. Next wave. Absolute value of sine, 200 hertz, 300 hertz, 400, 500, back to 100. Next wave. The semicircular wave. 200 hertz, 300 hertz, 400. This one's also really entertaining to watch. How about that? And this circular wave. 100 hertz, 200, and 500. Bell curve wave. 200 hertz, 300, 400, 500. And back to the square wave again. So that's my project too. And this thing keeps track of what it's outputting right here, and push W, push F, and if I get back to square wave, it'll show the duty cycle because that's the only one that the duty cycle is relevant for. And then you push D, changes the duty cycle. So that's it. That's project 2, the function generator. Next I'll hook this up to a speaker and see if I can hear the output. Thanks for watching.